structured effortlessly. That's the way it was. Happened so naturally. I did not know it was love. The next thing I felt was you holding me close. What was I gonna do? I let myself go, and now we're flying through the stars. I hope this night will last forever. Oh, oh, oh. Ain't nobody loves me better. Makes me happy, makes me feel this way. Ain't nobody loves me better than you. I've been waiting for you. It's been so long. I knew just what I would do when I heard your song. You filled my heart with a kiss. You gave me freedom. You knew I could not resist. I needed someone, and now we're flying through the stars. I hope this night will last forever. Oh, 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 oh. Ain't nobody loves me better. Makes me happy, makes me feel this way. Ain't nobody loves me better than you. At first you put your arms around me, then you put your charms around me. We stare into each other's eyes, and what we see is no surprise. Got a feeling lost for treasure, and love so deep we cannot measure. Ain't nobody loves me better. Makes me happy, makes me feel this way. Ain't nobody loves me better than you. Ain't nobody loves me better. Makes me happy, makes me feel this way. Ain't nobody loves me better than you. I got all this stuff waiting just for you. I just gotta know that your love is true. Can't keep running, boy, in and out my life. Wanna be your girl, cause the mood is right. So going on tomorrow, will you hide? Will you be there for me when I need someone to hold? Baby, don't misunderstand. I don't want you for my man. I just need you to talk before I invest my life. Don't walk away, don't walk away. My love won't hurt, no, no. Don't walk away, don't walk away. I'll be right there for you. Don't walk away, don't walk away. My love won't hurt, no, no. Don't walk away.
Hello, good morning, everyone, and welcome. Thank you for joining Fujitsu private session this morning. My name is Shingo Mizuno. I'm your host to the next 90 minutes today. I'm very excited to be here with you in MWC in Barcelona. I would like to start with quick introduction of Fujitsu and our network business. Fujitsu is a global DX company, and our purpose is to make a world more sustainable by building trust in society through innovations. As the world changes very rapidly, we base our action on this purpose. And also, this purpose defined by every person in Fujitsu. With respect to the network business, our purpose is to providing and trigger network innovation to improve society. To achieve this, I'm most certain that having open network is key. With increased vendor diversity, the network will become more flexible and efficient, enabling higher performance and energy efficiency through the optimum network configuration. However, we understood there are also some challenges in deployment open network. For example, concerning around network trust. However, I understand first is the briefing of Fujitsu effort on network security. I'm sorry. So today we will be delivering that program focusing on network trust to address these issues. First off, a briefing of Fujitsu effort on network security by our SVP, Nathan, followed by presentation by Professor Yuval Elovich of the Israel's Ben Gurion University, who is leading expert in these areas. And a panel session with guest speakers, including Dr. Victor Bao from Microsoft, and Dr. Sadek Abeta from NTT Docomo, and Diane Renaud from Open RAN Policy Coalitions. Our goal today is for you to walk away having better understanding of network trust in the open network and to cast aside your concern. I believe that open network will open doors to whole new ecosystem and whole new era of network technologies. I put later in MWC term, together let us unleash tomorrow's technology today here at MWC. I'm looking forward to having fruitful discussion with you. With that, I will hand over to Nathan.
Thank you, Mizuno-san. Good day, everybody. I'm just waiting for the cue. This is probably the wrong deck. Wrong presentation. Know any good jokes? Okay. Network security. So as Mizuno-san mentioned, my name is Rod Nathan. I'm the SVP and General Manager of the Photonics Systems Business Unit. And I have the honor today to introduce what we're doing in network security and trust as a company and how the role we play in the industry in that regard. Mizuno-san mentioned our purpose, and there's underlying that purpose, there's 5 key technologies that the company is focused on: computing, AI, networks, data and security, and converging technologies such as digital twins that bring the physical and virtual worlds together. On the network side, our technology focuses its innovation around open networks, as Mizuno-san mentioned, around intelligent networks, introducing AI into these networks for automation, and around sustainable technologies, but very importantly around security and trust as well. Our network portfolio consists of key technologies from the most efficient, dense, and high-performance low-power radio units to O-RAN compliant virtualized CU and DU technologies. From there to the wireline side to 5G transport and in the mobile edge part of the network, both mobile front haul, mid haul, back haul, onto terabit transport in the metro and regional and long haul parts of the network using the ultra optical system, which is a high performance optical platform. These are supported by several key software offerings such as the 5G service management and orchestration, network automation through AI and machine learning, and open optical network control. This is multi-vendor control and orchestration of the network. And those are again supported by service capabilities such as the integration and lifecycle services, and consulting services around ORAN security and network trust. As the networks evolve towards becoming intelligent via AI and virtualized via containerization and open via standards like ORAN, like Open ROADM, like OLS, architectural decomposition and disaggregation enables networks to become more modular and to become virtualized and cloudified. These have key supply chain benefits for our customers by creating a multi-vendor ecosystem that avoids vendor lock-in and enables new levels of velocity in innovation. And that can drive business growth for them. That's the belief, and this is the logic for why we do open networks. The challenge is that these new architectural components increase the attack surface for bad guys. Attack surface increases through multi-vendor modularity, through frameworks that support micro apps that people can attack, and even multi-vendor micro apps, through AI data training, open source software, and open interfaces and APIs that can be exploited, as well as the virtualization infrastructure that we have in the cloud. And unlike typical cybercrime against IT systems, telecom cybercrime can be self-monetizing. And there's a number of examples of this, but this provides motivation to a host of bad guys, such as insiders, hacktivists, cyber criminals, script kiddies, cyber terrorists, even nation states. And they're leveraging these vulnerabilities in the network from DDoS to man-in-the-middle attacks to contamination of AI training data, and you're going to hear more about that from Dr. Yuval, or Professor Yuval today. Fortunately, there is an ecosystem of good guys out there that are collaborating across the numerous industry initiatives and their supply chains to combat these risks. This includes industry alliances, government agencies, service providers, research organizations such as universities, the network technology innovators like Fujitsu, and our industry partners. Alliances like ORAN is one way that this ecosystem can come together to strengthen network security. Open standards enable all eyes to be on the prize. And that's based on the premise that transparency builds trust. And this is actually a proven concept. It has benefits similar to federations, which have increased security in networks, in IT systems today. ORAN Alliance Security Working Group is directly addressing network security through modeling and specifications that adopt security principles based on zero trust architectures. This builds on the other security standards work from organizations such as 3GPP and the Cloud Native Computing Foundation. And on top of that, or supporting all of that, is DevSecOps frameworks that companies are using and customers are using to develop and build these products. I'd like to invite you to the Fujitsu booth to hear more about what we're doing in terms of contributing and investing in these areas to advance security, such as network security lifecycle through our DevSecOps frameworks that we are developing and using, through network security services such as consulting, through contributing to standards in these ORAN efforts and other organizations, as well as the advanced security research that we're doing. And that brings me to miss a slide, jumped ahead. One important example of that research that I mentioned is the announcements that Fujitsu has made when establishing the Fujitsu Cybersecurity Center of Excellence in Israel. This is at the Ben-Gurion University, and also we've established the Center for Advanced Data Security, including network trust and security. And that leads me to introduce our next speaker, who is actually a luminary in this field in security. He's a professor at the Ben-Gurion University in the Computer Science and Information Systems Engineering Organization, Professor Yuval Elovici. Here you go. Thank you.
Thank you very much. Let's see that I get my presentation. Yes. So hello, everybody. I'm going to talk to you about the evolution of cybersecurity in network, and especially talking about the domain of AI. First of all, a brief history. By the way, the pictures that you are going to see here were generated also by AI, by Midjourney. It's very convenient now, like this one. So traditional networks, first of all, they were very, very physical. And from the point of view of the attacker, the attacks were very, very predictable. Usually, the attacker tried to tap into a location in the network in order to be able to do some kind of an attack. Then we moved from traditional to virtual networks, where we can actually build virtually all the structure of the network. There is a network administrator that can manage the structure of the network. And in this case, from the point of view of the attacker, if he managed, for example, to hack the network administrator station, he could actually even change the structure of the network in order to be able to do his attack. And from our point of view, the attack surface increased dramatically. Then we moved from virtual to intelligent network. When we are talking about intelligent network, we are putting AI inside the network. And an AI is being used for two purposes. First of all, to improve the management, the quality of service, the traffic engineering, everything is being manipulated or done using AI. And on the other hand, we are using AI to implement very, very advanced network security solutions, like, for example, intrusion detection systems, malware scanning, all of them are based on AI. So we actually embed AI in our network, both to optimize their performance from one hand, and on the other hand, to protect the network. But then we are going to show you that actually the AI component may become a major vulnerability of an intelligent network if you are not aware what attackers actually can do to manipulate and fool the AI component. So let me give you two examples, two threats to intelligent networks. Now, they are very, very extreme examples. On one hand, I'm going to give you an example of how actually attacker can compromise the AI component of a cyber defense system. And on the other hand, I'm going to show you how actually attacker may attack the AI component of a network in order to change, for example, something about its behavior. So first of all, about the first use case. We call it timing-based adversarial network traffic reshaping attack. I talked to you about the fact that actually AI is being used for protecting the network. For example, in the case of network intrusion detection systems, their goal is to try to detect in a generic way attacks inside the network. Now, they are being based on two types of technologies. One of them is signature-based network intrusion detection system, where we are trying to create, sometimes using AI, a signature that will allow us to detect certain types of attacks. But in many, many cases, we are confronted with an unknown attack. To be able to detect unknown attack, we used anomaly-based intrusion detection systems. And in this case, we are trying to model, using AI, what is the normal traffic behavior in the network. And in case that there is some kind of a deviation, it may indicate that there is an attacker in the network that actually makes the network to behave a little bit differently. And based on that, we are actually detecting the attacker. So it's using AI. But what can go wrong here? What could be the threat model? First of all, the attacker may know that there is a network intrusion detection system in the network. He knows that it exists. So from his perspective, it's a black box. The attacker may have an access to the network that it wants to attack. So actually what the attacker can do, it may adapt his attack based on the behavior of the typical network traffic in order not to be detected. But the attacker knows that there is a network intrusion detection system based on AI in the target network. So what actually the attacker can do? And this is a little bit tricky. So let me show you how the attacker actually can employ AI to fool AI. So I told you that my assumption is that the attacker managed somehow to get a foothold at the target network. And what the attacker is doing, he has a certain agent monitoring the benign network traffic. So the attacker actually is monitoring the traffic, and it trains its own model that can learn what is the network traffic behavior in a specific target. So for example, the attacker can measure the connection between a packet size and the following inter-packet delay of benign traffic before he's launching the attack. This is doing using, for example, LSTM, which is a deep learning algorithm. I can learn the connection between a packet and the inter-packet delay in a benign traffic in the network. And then, once the attacker learns that, how the typical traffic in the network behaves before launching the attack, he can take his attacks and reshape them based on what he learned. In other words, when the attacker is sending the first packet, his model will tell him, look, in this network, the inter-packet delay is supposed to be this. And then he sends the next packet based on this inter-packet delay. So actually what the attacker is doing is mimicking the benign traffic when he's launching the attack. So actually he cannot be detected because he behaves exactly like the benign traffic. Just to illustrate that, you see here multiple types of attacks that are being detected easily by anomaly detection algorithms. You see the detection accuracy of each one of the attacks. Let's take, for example, active wire trap. In this case, in active wire trap, the detection accuracy is very, very high before I'm launching the attack. But after I am reshaping my traffic based on the normal traffic in this network, suddenly the detection accuracy decreased to 0. And you see how the detection accuracies decreases because the attacker is using AI and it is reshaping his attack traffic in a way to mimic the traffic in this specific target network. Let me move to the second example, in the case of O-RAN. As you know, O-RAN includes several layers, like the radio unit, distributed unit, centralized unit, but the most important one is the RAN intelligent controller. In the RAN intelligent controller, we have AI components. You see, for quality of service optimization, for slicing optimization, mobility optimization, all these are components that are supposed to manage the network using AI. Now, what can go wrong here? So let me give you one specific application, which is intelligent traffic steering. The goal of the intelligent traffic steering is to monitor the quality of experience of different user equipment, and based on that, to allocate to the user the best optimal cell that can provide him the best quality of experience to that user as the user is moving along different locations. So we can see here in this example, we have a user equipment. There are 3 possible cells that may provide him service. And here comes the question, which cells will provide him the best quality of experience? So how actually is being done in this case? First of all, we have an anomaly detection component. We have the KPI monitoring that receives sensor information both from the cells and from the user equipment itself. Based on this data, it detects user equipment matrices that indicate that the user is experiencing some kind of an unstable quality of experience. So maybe we should allocate for him a different cell. Then this information is being sent to the traffic steering algorithm, and the traffic steering algorithm asks the quality of service prediction algorithm, which is based on AI, please tell me, given the current situation of the cells and given the current experience that the user equipment has, what's supposed to be the best cell that is going to give a better service to this specific customer? Okay, so the traffic steering listens to the anomalies, the KPI monitoring measures, and eventually we can give the user the best quality of experience. So you see the data is flowing from the user equipment via the RU, DU, CU to the KPI monitoring, which monitors both the sales behavior and the user equipment measures. Based on that, anomaly detection is being captured, and that's how we compute the next cell that the user should get in order to have a very, very good quality of experience. Now, what can go wrong here? Now, the attacker is not naive, but the attacker has control over the user equipment. So in other words, the sensory information that we are collecting from the cells is under our control as a telecommunication company. But the information that is coming from the user equipment is under the control of the attacker, because the attacker may compromise the user equipment, and he can send any sensoric information to the network that is going to benefit him. So what the attacker actually can do, he can generate sensoric information from the mobile phone in a way that will fool the AI algorithm to give the impression to the operator that actually I'm not experiencing a good quality of experience or quality of service. And then the AI algorithms here are going to think that maybe I should get a different cell. So actually the user can force the AI algorithm to change the cell, where actually I have a very, very good quality of experience, because all the information is coming from the mobile phone, and if the mobile phone is compromised, the attacker can control which information the AI algorithm receives, and by that it can fool them. And here you can see how the attack actually looks like. Initially, the attacker has a good quality of service, but is misled the AI algorithm by providing the wrong data in a very sophisticated way. We call it adversarial attacks, where we are fooling the AI components, in this case of the ORAN, and then the ORAN gives us another cell where actually we don't deserve to get another cell. And that's a huge problem, because in this case, all the sensoric information from the user equipment is under the control of the attacker. And it's very, very hard for us to put a detection mechanism inside the ORAN that will tell us, look, this actually user is fooling us, and actually is fooling our AI algorithm, and actually it has very good quality of service. But the quality of service is derived based on what the user is telling us. And that's a huge problem, because in this case, the attacker can fool the AI component inside the intelligent network, in this case, ORAN. To conclude my talk, I want to move to talk about robust geolocation. It's a work that we are doing today together with Fujitsu. You know, it's very strange to me, because in the past, I was focusing on the attack domain of how actually to fool my location for different purposes. We are going to talk about it later on in the panel. What's the motivation for an individual to fool about his location? But what we discovered, we started to work on this topic with Fujitsu, is that actually it's relatively very easy today to mislead about your actual location in the internet. First of all, we can delay the location spoofing, and by that to fool our location. There could be a route bending, so we will not be able to know on which route in the internet actually our traffic is passing. There is a question of which cloud provider actually we are communicating, because there are cloud providers that provides our services in different locations. So it's very, very important for us to know which cloud site we are actually communicating. So it's very, very important to know the location of the cloud provider, but even that can be fooled very easily. So what actually is the real problem? There is a perfect technology to do IP geolocation. The problem is that it's not trusted. So as you can see here, I can compute the geolocation of a specific entity using probes. I have, in this case, 3 probes. The probes we know the location of these probes. These probes, for example, are going to send pings toward a specific target, and based on the delays, they will roughly, each probe roughly knows where is the location of the target. By intersecting the measurements of 3 probes, we could know that actually the location of the IP is probably in this area. But as you see, everything is based on pings that are not trusted. Now, what the attacker can do if it wants to mislead us about its actual location? As I told you, pings are not trusted. There are 2 types of manipulations that the attacker can do. First of all, when somebody is sending me a ping, I can actually delay the response to this ping. So I can manipulate the actual measurement. Secondly, since the pings don't even include a sequence number, theoretically, not theoretically, practically, I can send the response to a ping before I even got it. Because usually the measurement is not being done by sending only one ping. It's a multiple pings. So I'm getting the first ping. I'm going to respond to it, but then I know when to respond to the next ping before I'm getting it. So actually I can shorten the round trip time and I can prolong it. And if I can do that, practically I can control exactly my location. So originally, the location was here, what you saw before. But now, I have a fake location that I want to whoever tries to measure my location, I want to tell him that it's actually my location is here. That's my fake target location. So what actually I'm doing the following. For these 2 pings, I'm going to delay the response. And for the next one, this one, I'm going to respond earlier. So I'm going to shorten the RTT. The consequence is that my measured location is going to be in this area. So I'm actually misleading about my location from here to here. And today, in the current state-of-the-art technology of network measurements, it can be easily done, and there is no solution for that. So actually, we are working today with Fujitsu, and trying to help Fujitsu, Ben-Gurion University, and together with Fujitsu, we're trying to develop new technologies in order to allow us to solve the following problem. First of all, developing robust and trustworthy IP geolocation techniques. Then we want to verify that the IP geolocation is correct, and we want to make what we call adversary resilient geolocation, which is a very, very important because many, many services today in the internet are relying on the location of the entity that we are communicating with. And today, there is no way to trust the location of the entity based on network measurements. What we want to do, we're going to present the problem in the IETF 160 in Yokohama. We are going to present this topic to the community. We want to propose a new standard of how to do robust geolocation, and we are going to demonstrate the risk using 2 demos. The first one is going to do using the RIPE. The RIPE is a platform of 11,000 probes, and we are going to show a live demo where we actually fool our location. There is a server that is going to be in a specific location, and by launching an attack using the RIPE probes that we are going to do the actual measurement, we can fool the location. And secondly, we are going to demonstrate geolocation spoofing playground using NS3. And again, the goal is, first of all, to show that there is a very, very big problem in the domain of trusted geolocation. Actually, we don't have a trusted geolocation infrastructure today, and we want to propose, together with Fujitsu, an idea of how to make geolocation trusted. Of course, it will require a change in the internet protocols. Thank you. Thank you very much.
Good morning. I'm Femi Adeyemi. I head the wireless business for Fujitsu in Texas, North America. So today, the wireless network is experiencing a lot of changes. We're going from traditional networks to virtual networks to automated networks to intelligent networks. So it's really an exciting time in terms of what the network is doing. We are coming up with new names today. You will hear of brownfield deployments, greenfield deployments, blueprints. There are so many names that we come up with now. You have RIC. I don't know what RIC did to us, but now we have RIC. So many good things are happening on the network side. New entities have been introduced into the RAN space, from software to hardware. We have a lot of new entrants coming in. But then there's a lot that we're also hearing about security, network trust. Professor Yuval just talked to us about AI and so many other things that are happening. So what we've done is we've assembled today an eminent group of panelists that will help us to really focus on network security, network trust, so that as we invest, as we research, we can begin to look at how to make this network trust a reality. How do we securely transition from physical networks to virtual networks? So allow me to introduce and bring to the table today, to the seat today, our panelists. I welcome Professor Yuval from Ben Gurion University, please. Thank you. Dr. Victor Baal from Microsoft. You're welcome. Dr. Abeta San from Docomo. Hi. And lastly, because I want her to sit next to me, Ms. Diane Ronaldo from ORPC. Please, please. So thank you very much for joining us, panelists. What I want to do is to spend 2 minutes each from all of us to help us to understand what you do and how that relates to security, for example, trust. So I'm going to start with Dr. Abeta-san from Docomo. So what do you do, and how are you connected to security? Please, help us.
Okay. So first of all, thank you very much for inviting me. My name is Sadayuki Abeta of NTT Docomo, leading the Open RAN in NTT Docomo. So we already deployed the open network from 2020. Actually, for 4G network, we also achieved the multi-vendor network with Fujitsu. So we have experience for the multi-vendor or open network, and we didn't see that big issue for more than 10 or 20 years. So what we are doing in that, for security, so first we define the security functionality in standardization. So, but this is common for all closed network or open network. It's a common for that. So all the equipment, I think, supported. And we also have security, but security is sometimes hard to say because it's not disclosed. It's disclosed, you know, that easy to see that. So, but in the network side, we introduced that security functionality, of course, and that is physically, logically, and different functionality we have. And as for the open network, I couldn't disclose, but you know that open network, we can see what happened from the other equipment. I mean, if some malware functionality in the one equipment, the other equipment developed by other vendor can detect it. So mutual monitoring we can achieve in that multi-vendor network. Yep.
Thank you so much. Professor Yuval, what is your area of research? Tell us a little bit about yourself, the work that you're doing with Fujitsu, and where you're going with such research.
Yes, I'm working for many, many years on cybersecurity. And I think for the last 10 years, I worked a lot about utilizing AI in order to solve cybersecurity problems. Because I saw the potential in doing it in a very, very systematic manner. But recently, in the last 3-4 years, I discovered that actually a huge vulnerability lies inside the AI itself, regardless of where you are using AI. And I believe that the attackers are going to focus on attacking the AI component in order to achieve something. And it could start, for example, from poisoning somehow the training set that is being used to induce a model. And then it will give them a huge advantage because they know exactly how they actually poisoned the model, what is the inherited vulnerability inside the model. It's one example. So wherever AI is being used, I believe that the attacker is going to move and to try to fool these algorithms. Okay. And for that reason, the lab that Fujitsu established in Ben-Gurion University is focusing primarily on AI security. Actually, we are doing the AI security for Fujitsu in different use cases. I think one of the most beautiful use cases that we are currently doing for Fujitsu is to demonstrating how actually an attacker can fool an AI-based shopping cart. So when you are bringing a product in a supermarket, the AI will be fooled and is not going to classify the product correctly.
Wow.
This is one example.
Okay.
And of course, we are provided Fujitsu a unique technology how to identify attempts of customer to fool an AI-based shopping cart.
Right.
And of course, since I noticed that AI is so much embedded in intelligent networks, I'm sure that the attackers are going to move and to try to attack the AI components of intelligent network. And our goal is to try to develop for Fujitsu advanced technologies to mitigate such type of attack and to make the AI component of intelligent network dramatically more robust.
Thank you very much. Dr. Barr.
My turn. Okay, so
Introduce yourself.
I work for Microsoft. I spent a majority of my life in Microsoft research. And over the last 3 years ago, I'm a technical fellow. I was asked to move into the product unit, which is now called Azure for Operators. And so if you've probably seen a lot of announcements from Microsoft for many products. And the bigger idea here is, of course, to bring the cloud infrastructure and the telecom infrastructure together, because there's many, many good reasons to do that. In terms of security, so all through my life, as I've worked on different projects, security has always been a thing that you have to consider. And companies like Microsoft, which are sort of a cloud company, we have millions of servers. We have 62 regions, 180,000 miles of fibers connecting them. We have something of the order of 43 trillion security signals that are processed every day. So the point I'm making is that security is very fundamental to pretty much anything we do in the cloud, because the cloud wouldn't exist without the trust that companies have. And very major companies, financial banks, healthcare, they all sort of trust the cloud to use their data properly. So now when you think about 5G or the next G, and you think about like what is happening there, you sort of see that we went from a hub and spoke model, which was in 4G, where you had one vendor, and then to a more disaggregated model, which is where you basically bust open the hardware into different components.
Yes.
And now that creates the vulnerability that we worry about.
Right.
So I have other things to say, but I'll stop now.
Okay, that's fine.
And then yeah, we can
We
go
will
on.
continue. So, ladies and gentlemen, so we've started from the operator side, research, platform, and now to Diane, that will be from a different perspective. So, Diane, help us to introduce yourself and what do you do?
Yeah, thanks, Femi. So I think it's important for my background. About 10 years ago, I worked for the House Intelligence Committee. I was their first cybersecurity staffer. So what I do today at the Open RAN Policy Coalition is not so different than what I did at the House Intelligence Committee, where I talked to smart security, cyber experts, and I was able to condense that information
Yes.
and then bring it to policymakers and have a discussion about what can we do, how can we provide them the right tools, what type of information do we need, how can we ensure businesses are receiving the same type of information that the government has. And so at the coalition, we do something very similar. They were able to work with our members, and Fujitsu is one of our founding members,
Yes.
to be able to communicate to policymakers globally. And at this point, we've had conversations with 50 countries around the world about how we can advance principles of Open RAN. And a part of that is security. And people want to make sure that security is baked in, that we're taking it seriously, and that as we build out these global networks, that is at the forefront of the conversation.
Excellent. So now we want to unpack this, okay? And I would like to start with you. So recently there's been a lot of focus on security. Oh, it's not secure, it's secure. We don't even know what we're talking about. So why is this a good thing that we're talking about security now? Is this a good thing? Is it a bad thing? Are we scaring people? Help
Yeah,
us.
no, and it's absolutely a good thing. I think sometimes there might be a mentality, if you're talking about security, something might not be secure.
Yes.
That's absolutely not the case. We want to make sure that we're being transparent, excuse me, that we're being transparent, that we're able to share information, what one company might have, another company might need as far as a threat vector coming down. I think there's a mentality, and it's taken a while to get here, but there's a mentality that all this information raises all boats, and we're all in this together. I mentioned I was at the House Intel Committee when this issue really started first percolating,
Right.
where companies were willing to come and talk to us in the skiff and tell us they had been hacked, but they would never go public with it. But we've come so far from that point where people are more willing to come out and talk about their attack, talk about what they did to mitigate that attack, to now we joke, if you don't say that you've been hacked, you obviously have nothing worth stealing.
Yeah, that's true. So Victor, is securing the telecommunication network fundamentally different from the cloud network? Microsoft has been in this business of cloud for so many years. So is there a difference?
Yeah, so it's an interesting question in the sense that, I mean, it's a straightforward question, but let me go at it the following way. So the cloud has to be secure, right? I've already sort of made that point, and I can make it again, but nevertheless, cloud has to be secure. And the cloud deals with distributed systems, so it's
Yes.
sort of like, it's not a sort of a monolithic thing. You got services that are operational in different parts of the different servers and different things. So now when you think about 5G, a lot of that is in the new architecture for 5G, right, which got disaggregated. So there was a general fear that now you've got a bigger attack surface, many things can be pushed forward. But for us, it's the normal game. It's not sort of a new thing. And I'm purely speaking from a Microsoft perspective.
Yes.
I'm not sort of like, I can completely get that, from the outside, you're sort of thinking, oh no.
Correct.
But what I'm trying to say here is that we actually have, I don't know how many people know this, we have a $20 billion security business, right? We have like thousands of like really smart, good, seasoned engineers working on this stuff. And it's a sort of you have nation states that attack you.
Yes.
And so it's not like, even that is a big number to protect. But the point is that we understand the problem. We understand the problem very well, and it's very hard to penetrate, the cloud networks. And for the same reason, I feel like in the 5G space, we can protect. We have the tools, we have the knowledge, we have the infrastructure piece, but the convergence of the two industries has been slow a little bit. And so that's where the issues are.
That's where the issue is.
Yeah.
So I want to come to you at Better San. So one of the things that we're now doing on the RAN side is virtualization, containers, virtual infrastructure. But NTT Docomo has been in the data center business for many years. And I believe that a lot of the experience that you have in the data centers, you have brought that into the RAN space as well. So what is fundamentally different then when it comes to network security? Is this a new phenomenon for NTT, or you are utilizing the experience that you have before to secure the RAN network today?
Yeah, the security for that data center, of course, that we can have experience for that data center security, and the cloud part, I think we can reuse. Well, LAN side, we have, of course, different security scheme. This is the reason that usually the LAN, we connect to the different type of terminals. So we need to have the security functionality between the terminal and the LAN and the terminal to core. So multiple layer, we have the security. So for the cloud RAN, I think we can use that. That's mainly the implementation part. But so we need to think, or we need to discuss that the standardization future or implementation future.
Yes.
So standardization future is, of course, that it's quite different, but it's already implemented. And the cloud part is, of course, we can reuse. And we have the data center, and we have already introduced the virtual core for 4G era. So maybe we already use that more than 10 years experience for that virtualization core. And that experience, of course, we can share to our core team to run team.
RAN space, yes. Thank you very much. So, Professor Yuval, the trend now is the wireless network would adopt O-RAN. We are seeing a lot of that. There are a lot of announcements. Fujitsu has bet its future on open, as Rod helped us to describe. So why do you think adversaries will attack the O-RAN AI component if the telecommunications space adopt O-RAN? What is the driver for that?
Look, I think that the driver for that, first of all, attackers likes to attack places where it's very, very difficult to detect them. So I think that the motivation will be very, very high. And the biggest problem is the ability of the attacker to control the input to the O-RAN. Usually when you're talking about a system, you want that all the sensoric information that is being reached by the system is trusted. Now, in the case of the O-RAN, a lot of information that dictates how the O-RAN behaves is coming from the user equipment. Now, from my point of view, the user equipment is not trusted because the user equipment can be hijacked or can be hacked, compromised by an attacker. And suddenly, I have a very, very intelligent network system like the O-RAN that all the sensoric information is being fed by the different devices is actually under the control of the attacker. And it's very, very difficult for me to distinguish between false information coming from the user equipment and real information coming from the user equipment. So I think that the motivation for an attacker would be, first of all, because they cannot be detected. And they are not actually attacking, they are influencing the behavior of the network without attacking the infrastructure of the telco, which is amazing. And it gives them a huge control over which cell will give you a service, and also on the energy consumption. There are many algorithms that are going to be in the O-RAN to optimize the energy consumption of the different cells. Now, it's not under the control of the operator, because the attacker actually can control exactly how the energy consumption will be of the operator because he controls all the sensory information from the user equipment. But that's a very, very big problem.
But that's an area that you focus on, and you are going to help us to make sure it's very tight.
Exactly.
Thank you very much. So Victor, ransomware has been in the news lately.
Yeah.
In fact, one of the operators recently was just attacked as well. How is Microsoft handling ransomware?
So first one needs to sort of say, even mentioning things like ransomware is sort of like, In fact, there was a presentation and I had the word ransomware in there and said, oh, maybe you can remove that. So there's a fear, and it's true. It's been in news, and it's terrible because they take over the system and they can disrupt the communication infrastructure, the national network. It's just terrible. So while I spoke, I think, with great confidence about our ability to protect, I am practical enough and realistic enough that things do get compromised, and you never know, where the hole is. I mean, the comments you made are right on. One of the, in fact, if I just digress for a second, one of the national in the United States, one of the policy decision makers have had to sort of deal with that. Everybody from the device manufacturers, manufacturers have to be very responsible about this whole thing. Anyway, so setting that aside. So ransomware, so we take that into account that what if we get hit by ransomware, right? Then the problem with ransomware is not just the fact that you have to pay the money to get it going, but even when they bring the things down, bring them back up takes time, and and there's many evidence of that around many examples of that. So what we have been doing is we've actually built a mitigation strategy and a fast recovery strategy. So very simply, I'll just explain it. I mean, it's deeper than what I'm saying, but nevertheless, you will get it. So there's this notion of authenticated beacons that showed up. And if the infrastructure piece does not see that beacon, and that is possible because when you cut things off and all that, it just reboots. It just sort of brings it to the old state.
Yes.
So the new state that is infected does not have the ability to continue in the infection. So this is just one simple example of how we do it. So your question was, how does Microsoft deal with this? So Microsoft not only builds all these tools to protect, but also tools that in case you get compromised, get up and going very quick without having to
spend a lot of time.
So yeah.
All right, thank you. So Diane, in your conversations with global policymakers, what are the things that you are finding that resonate when it comes to security? Because this is not a local problem. It's not a US problem. It's not a Euro problem. It's a global problem. So as you travel and have conversations with policymakers across the globe, what resonates?
Yeah, so there's definitely, it's top of mind for all policymakers, all global policymakers. It's just not something that's unique to the United States. So I think that for them, it's just how we can break this down into easy terms. Very complicated subject, a very important subject, so they want to make sure that they have all the details. So explaining that Open RAN systems are 3GPP compliant, and they do abide by those security standards. That Open RAN Alliance does have a security working group, and they are focused on this specifically. And just the idea of, I know Rod mentioned in his conversation as well, transparency, that if you're going to have a multi-vendor system, you're going to have more eyes on it. And if you have more eyes on it, you're going to be able to do that detection and mitigation. We all live in a world of zero trust model and understand that it's detection and mitigation and shrinking that time frame. And when you have multiple people focused on the issue, you're going to help bring that time down and ensure that the network is up, back and running.
Oh, thank you. So Abeta-san, I want to come back to you because network virtualization now is real. It's been used many times on the core. We're now bringing that into the RAN space. So what is your view? Is there any added risk when it comes to security if we introduce virtualization into the RAN space?
So I don't see that any additional risk. Yeah, we have, as mentioned, we have already introduced the virtual core, but we didn't see that any issue. And LAN, as Lina already mentioned, we have defined that many security functionality in 3GPP, and that is common for even though the traditional LAN or virtualized LAN or so. And in case of the virtualized LAN, there are the multiple players. So we have the cost server or accelerator, and also the CAS layer and the software layer. Each vendor has their own security. So I think that that is good because that it's independently defined. So if one security features that attacked, but the other one broke.
Control.
So it's very hard to attack all the features simultaneously. So it's I think that open RAN or open network could be provide more strong security than the single vendor solution.
Thank you. So Victor, same question, but maybe repackaged in a different form. What are some of the advances in managing the cloud network that can now be brought into the mix of securing the RAN network?
Yeah, so actually this is it's a good question. So I would say virtualization in itself doesn't pose the problem that one might think. I mean, it's a new thing for the telecom industry to embrace, but virtualization has been around for decades, and so we sort of know how to do it, and we have this zero trust architecture, so we don't. I think one of you mentioned that the fact that and you also mentioned the multi-vendor stuff, it sort of comes together in this ORAN type of a thing, and so now you have to enforce the zero trust because the different vendors are putting things together and they have to trust one another. I think that's kind of what you were saying too. So that's new. That's a little bit new than, let's say, the cloud basis where it's just one vendor, it has the connection to that. So you asked the management question. I think management is actually very supremely important in any of this. In fact, the whole push towards trying to bring the cloud infrastructure together with the telco is very much about management. And so you have the ability, the automation of stuff is very important. So in terms of security, the automation, we have tools. For example, if you're aware or not aware, there's a tool called Sentinel, which is, think of it as like probes that are like put into different places, and they're all the time giving you information. We have tools that we are building in the RAN space, which are RAN analytics, so analysis. We actually able to get the data, and then we are able to correlate the data properly, and from that correlation, we are able to sort of figure out if bad things are happening. This is security, but it actually comes in the management pocket of things, right? Because you're managing the network, and you got all these things working together, and then you have a dashboard which will alert you when something happens. So that's, I guess that's the answer is that the management provides all the data that you need directly from, because now RAN is a lot of software, so you actually have the ability to get data from the entire stack, from the bottom right up to the top. And so your ability to actually make sense out of that data goes up. And we already have tools to do that. We're going to bring it into this space. So
excellent.
Yeah.
Diane, and I'm going to come to Professor Yuval shortly, but to you, how can vendors and operators participating and working together today become more involved in ensuring that we secure our network systems?
Yeah, so for the US-based companies, there's these organizations called information sharing, ISACs, information sharing centers, and they work through the Department of Homeland Security. So they allow sector-specific, they do cross-functional sectors to communicate on what they're seeing, sharing best practices, and then in turn, the government provides intelligence typically classified on what they're seeing on their systems so companies can better protect themselves. So there are organizations out there that exist to help spur that cybersecurity within companies, small and large.
I see. Thank you. So Professor Yuval, you talk about location, and a lot of research is now being done in that space. Location has always been a characteristic of the network. So what is the motivation for someone or an entity lying about their location? Is there a benefit for such things?
Yes, I can give you a very, very funny story from Israel, at least, just to explain to you why the location is matters from a financial point of view. I own a Tesla, and many people in Israel are owning a Tesla, and the taxes in Israel are very, very high when you are buying a car. So if, for example, you buy a car, a Tesla with the most advanced autopilot, you need to add an additional 82% taxes when you are buying it. So what people did in Israel, and I will tell you why they did a huge mistake later on, they actually bought it without the advanced autopilot, and then they connected the car to Germany, and then they bought it tax-free and upgraded the car. But the idiots spray it over the social media, so it's reached the tax authority. The tax authority went to Tesla and tell them, do you know that where is the car is? Eventually, the car is driving in Israel, so you know it's in Israel. And they obliged them to remove it from all the cars. This is an example of a financial benefit when you are actually fooling. But in this case, Tesla knows where is the car. But specifically at that point in time when you are wanted to buy it, you actually fooled their system about your location, which give you an amazing benefit. So there are many, many benefits for attackers to mislead whoever wants to know their physical location. And by the way, there are many, many fraud detection systems that one of their important parameters is the location of the person that is accessing the service. And if you can actually fool about your location, actually you are misleading or modifying one of the most important parameters for the fraud detection system, and then you are not being detected. So these are just two examples of how actually you can benefit from misleading a specific service about your actual location.
But let me check with you on something. That is not fundamental. That is always there, whether you are open network or closed network.
Yeah.
So when people are talking about security, open versus, are we just misleading and confusing each other? Because whether it's open or closed, a location problem will always be a location problem. What is your view?
Look, but in many cases, I want to know for sure from where the data is coming. For example, if there is a specific sensor in the internet that is measuring the height of water in a dam.
Right.
So I want to be sure that I'm communicating with him. I want to be sure that the traffic is not routed via some entity that can actually modify the content of the water in the dam. So the issue of trust about the location is very, very, very important.
That is true.
If I may add something
Please.
here. So I was thinking of an analogy which is not location. So I'm not sure if this works, but I'll try. So one issue that comes up is the configuration, the human issue, which is that you often go and sort of configure things, and we often find that things go down because of human error more than the sort of the security thing. But
Right.
it looks like
Yes,
security,
it looks
right?
like security, yes.
So there are ways to deal with it. So I get the geofencing part, sure. But the other way sort of we deal with things is verification. So the software verification has been around for a long time. Network verification is now a deal for several years. And so one of the things that happens is the SLA for clouds, for example, it has to be up all the time. And so the way we prevent human error from happening is that nothing actually gets configured or touched on the underlying network or anything till it's verified. And it's a very sophisticated technology to do that. It's not easy to do that, but nevertheless, it works really well. So in the example that you have, you could actually put verification technology before anything is downloaded and all. And that might be a way to deal with this. But anyway, I just thought
That's very interesting. So Diane, I don't want us to leave this state without talking about the state of security specifications globally. You are involved in some of that. Can you expatiate on where we are? What are we doing? Where are we going from a specification point of view?
Yeah, no, so as we all know, security is not static. We're always working on the newest thing. How can we better ensure that we have the information that we need? How can we make sure that we have the tools that we need to continue to secure our networks? As I mentioned, the Open RAN Alliance has a security working group, so they are constantly working through the different machinations of that. I would say that I have worked on several security papers, one with the Enduring Security Framework on Open RAN security. There's been one through the FCC that was recently concluded, and so that you do have industry coming together with governments, which is private-public partnerships is the best way to go about these, understanding that both have a lot to add to the conversation and have a vested interest ensuring that networks are secure. So constantly moving,
Yes.
but it's good for that Open RAN Policy Coalition continues to be an important part of that conversation, and we can continue
Excellent.
to drive momentum forward.
Thank you. Better-san, so what are some of the open problems that Docomo is working on in this area, in the security area? Can you just quickly help us with that? What are the other areas that you're looking at?
Yeah, first, we don't see that big issue in our Open RAN. And I think that so in case of Open RAN, multi-eye check the specification, not single eye. So multi-eye check specification, multi-eye checking the implementation. So we can if something included in that specification, we can find it in a very short time and fix it before something happens. Because even though something happens, multi-eye can check it. So open case, I think that actually our case we use the open network, and All Alliance also checking that specifications, and they have already fixed that. No issue, but the kind of the security flaw in the front flaw, but that they already fixed it. They already defined the security functionality. So I think that open mean that we can more strong security checking as multi-eye.
Yeah, thank you. Same thing to you, Professor Yuval. We can't say that, oh, it's all secure. Then research stops. Bad guys are running wild. So what are the other interesting areas that you're looking at from a security point of view?
First of all, I like very much the topic of AI, especially when AI is evolving. We can see now domain like ChatGPT. So we started to enter and to see how attacker may employ ChatGPT, for example, to do new types of attacks. For example, I want to compose a dedicated spam email. I think a ChatGPT is an amazing platform to ask him to compose me a very, very convincing phishing email. Attackers that want to obtain information about how to launch attacks, they can actually ask ChatGPT. So I'm very, very intrigued now about how attacker may use ChatGPT to lower the cost of their attacks. That's a very intriguing domain for me, at least.
Thank you very much. I want to end with
Sure. I actually mentioned a few of these things. I meant to mention the verification stuff. I mentioned the RAN analytics. I mean, one of the things that people have gotten seem to like a lot is this notion of programmable RAN that we are pushing. And the idea there is essentially that you can insert codelets. These are like small pieces of code that can go and operate at near real-time rates without affecting the RAN chain, but will give you pieces of information that you wouldn't have otherwise gotten. So we sort of take that, do the analysis. We're working on that stuff. We're also the AI is the ChatGPT. I was smiling because I get what you're saying. I don't know how many of you have had any experience with that. Just to sort of add to that, GitHub now has this thing called Copilot. You can actually ask it. You can write comments, and it'll write the code for you. This actually lowers the entry of these people who want to attack, because they don't actually have to be very sophisticated coders, as he was mentioning. So that's also on our radar to do these things. And yeah, and we started this panel by, I sort of talked about the disaggregated nature of the software and the zero trust. So there are tools that we are trying to sort of fit into this new domain. And as we find any holes in the process, we sort of fix those things.
Excellent.
But they're well thought out, yeah.
So in wrapping up, it seems to me from our discussion, network security is real. It's a challenge. And it's evolving. So we are not going to stop, whether that's from the operator side, from research, from policy, from platform. We will continue to figure out how to secure our networks. The bad guys are not sleeping. Yeah. They want to monetize this. So we cannot be fighting each other. It's closed, it's open. the community has to be concerted together to fight this. Global policy is important because we bring governments together so that we raise the standard. Diane has been very busy in that area, in that space. And Fujitsu, we are also investing in research, in how we build our products, in consultancy, in so many other areas, just to make sure that as a community, security is paramount to us, it's important to us, we focus on it. But for me, the infighting needs to stop. It's open, it's closed. Then we're allowing the bad guys to just continue to attack us. So it's an interesting topic, and I'm very grateful. I want to thank our panel for spending the time with us in Fujitsu today to dive into this very important problem. Ladies and gentlemen, please clap your hands together for the eminent panel that we have. Thank you very much. Dr. Abeta-san, thank you. Professor Yuval, thank you. Dr. Victor, thank you.
Thank you.
Thank you for
And
moderating.
Diane, thank you very much. Thank you. Thank you.
Thank you for attending MWC Barcelona. As you leave, please ensure that you have all of your belongings with you. We would like to wish you a safe journey home and look forward to meeting you again next year.